that one that looks complicated is not really, but you have to be careful. So 42, y equals the square root of x plus the square root of x plus the square root of x. That's when that order that I suggested from the outer to the innermost will really help. So y prime or dy over dx. Why do you think this is important notation? I kind of mentioned it a few minutes ago. See, if I'm given y and I don't look here, I really don't know what is the independent variable in y. But if I ask you find dy over dx, now you know exactly what is the independent variable in y, because I'm differentiating with respect to it. But here, when I determine y prime, I'm not really telling you. If you don't look here, you'll not know that the y is a function of x. But this is very clear. If you're asked to differentiate a function y with respect to x, then the variable in y must be x. Okay? Good. So let's differentiate the outer function. And this is how I show it to my students. So I differentiate a square root of a function. What will you tell me to write?
1 over 2 the square root of the function.
1 over 2, the square root of the function. Now I look, it's x plus the square root of x plus the square root of x times what? The derivative of this function.
So the
1
plus 1 over
plus 1 over, now I'm here. I differentiate this function. 2
square root
of x plus the square root of x times the derivative of this function.
1 plus 1 over.
Yes, in parentheses, 1 plus 1 over 2 the square root of x. Now careful, you have to close the parenthesis here, and you have to close this parenthesis. Of course, we're not going to attempt to do anything here. This is it. But is it clear what I just did? Maybe we should do it again. Yes? Perfect. So, I'm differentiating the square root of a function. Don't even look at the function. It's whatever this is. I don't care. I have to write 1 over 2, the square root of it. Agreed? Times the derivative of this function. Parentheses, of course. I differentiate x plus, now I'm here. The derivative of this function. What is the derivative of this function?
1 over
2 the square root of it times the derivative of this function, but in parentheses. 1 plus,
1 over some other notes.
that's it. Close the parenthesis and close this parenthesis, the outer one. So it really looked terrifying, right? Any questions? Any questions? Do you think we should look at other examples before we look at some applications?
Can we go over 44 from the book?
Yes, 44. 44, yes. Before we, yes, thank you for reminding me. Before we look at 44, let's talk about the following. I should not annoy this machine ever. Okay, when we differentiate e to the x, what do we get? Yes. When we differentiate e to a function, I know we just wrote those, but I need to connect the topics and the concepts here.
e to the function function prime.
Do we all agree with that? If this is just x, then I should multiply by x prime, but there is no need because that's 1. Okay. Now, let's suppose the base is not e, but is a number a. So I want to be able to differentiate a number other than e to x, and also a number raised to a function, not just x, but a function prime. So a to x prime and a to f. Okay, before we look at this, is there any way of connecting e to a or a to e? Because the idea here is that when I differentiate a to x prime, I get a to x, but multiplied by natural log a. Here, I should have showed you this with natural log e. But for the same reason we didn't write natural log e, for the same reason we didn't write x prime. Why we didn't write natural log e? Because it's 1. But as long as the base is not e, we have to multiply by natural log. We are changing the base from e to a. So therefore, the second one follows very easily, knowing that. What do you think when we raise a to a function prime? What do we get?
A to the function times the natural log of a. Wait, no, I think I'm lost.
Would be f prime times ln of a.
That's it. It's the same rule, but here it has natural log e, which there is no need.
So it's equivalent of multiplying 1 twice at the end? Is that what I'm looking at there?
No. Natural log a is not 1. Only natural log e is 1. We should have had natural log e here, but we don't because it's 1. But natural log a is not 1 because we are talking about a specific situation in which the base is not e. And now, knowing this, we can look at problem 44. So 44 has y equals 2 raised to 3, which is raised to x squared. Yes, I know, it looks like the previous one. Very complicated. Not at all. We take it one step at a time. I'm asked to differentiate 2 to a function. Okay, so let's write y prime or dy by dx is what?
Oh, would it be 2?
To whatever. I'm going to copy it right now. Good. Times what?
Oh, would be 3
Raised to x squared prime. I'll deal with it in a minute. Times ln. Exactly. So I only follow the rule. So a to the function, right here, times the inner function prime, which is 3 to x squared. I did not perform that operation yet, times natural log 2. And now we have to look at 3 raised to x squared prime, and we're done. So 2 raised to 3 to x squared times. I'm differentiating 3 to x squared. How do I differentiate 3 to x squared? Or 3 to a function? 3 to a function prime is 3 to the function times
2x.
prime, which is, yes, x squared prime, which is 2x, excellent, times
ln
ln of 2. Yes, we can't do anything to it. Other than put 2x in front, I can't do anything. You could write, you could combine these two and put +1 here, but there is no need. This is on a problem that looks very difficult initially. But please literally cover it while thinking. Okay, I'm differentiating 2 to a power. Okay, 2 to a power prime is 2 to the power times the power prime, the function prime, times natural log 2. I copy this. Now I apply the same formula again. 3 to a function prime, 3 to a function, times the function prime, times natural log 3, and I copy natural log 2. And I just rearrange it a little bit. It looks gibberish, but it's really straightforward after you practice it a little bit. Okay, so let's look at some applications. Are we ready for that? Any questions on this problem? Okay. Colby, is this okay?
Yeah.
Any questions, anyone? Okay, so let's take a look. You choose. I would like to look at this table, one problem with the table, maybe one problem with a graph. So we just cement the information we know right now. Maybe 74, it looks, from a distance, it looks just horrible. I'm sure it's not. And we can look at an application under certain circumstances. A rumor spreads with this function. Interesting application. Let's see what they are asking us to do. And then we can look at implicit differentiation. Okay, so what would you like to continue with? You want to look at the table?
Yep.
63. Part A or B? B, fine. So let's take a look. Yeah, maybe I should just show you here what we're talking about. Okay. So we're asked to find h of x, knowing that h of x is g of f of x. If h of x is g of f of x, they're asking us to find h prime of 1. Well, I can determine h prime of 1 before I determine prime of
X.
Correct. If I don't have the function, I can plug in anything. So let's first differentiate the function and then plug in 1 and see what we are looking for. Good. So remember, we cannot plug in a function, anything, before we get the function. Okay, so this is problem 63 on page 206. And we want h of x. And they say it's g of f of x. So let's determine h prime. Can anyone give us h prime? The outer function prime. That's it. So now h prime of 1 is g prime of f of 1 times f prime of 1. Where do I start? Obviously, I have to start with the inner, but this I can use it right away because I'm assuming it will be given to us. So we want to find f prime of 1. Is f prime of 1 given here? If f prime of 4 is, if prime of 1 is 4, perfect. Is f of 1 given?
Yes.
3. So I have 3 and 4 so far. Okay, so this is 3 and this is 4. What do I have to determine next?
Well, G prime of 3, right?
Exactly, g prime of 3. Awesome, that's it. That's the idea. Good, you have no difficulties with this. Oops. Good. So g prime of 3. 9. Excellent. Good, so we're done with that. Let's Perfect. So this will be 9 because this is 9. 9 times 4, 36. Good. We would like to look at the graph and read from the graph, or is it clear what we need to do with the graph? It's up to you. So yes or no?
Can we do a graph?
Yes. Choose a graph, please.
65.
65. Part A, B, or C? B as in boy? Okay, so V prime of 1. We are told that V of x is G of f of x. And we want to determine V prime of 1. Good. So let's write it down.
So it would just be G prime of f of x times
Yes.
prime of x.
Yes.
And then just
Right.
same function.
Exactly what we did before, yes. So V of x is G of f of x. So V prime indeed is G prime of f of x times f prime of x. And they want V prime of 1, which is G prime of f of 1 times f prime of 1. But now we have to determine first f of 1. And I need my pencil. So we want f prime of 1. Okay. At 1, no one can see what I'm doing. Sorry. So at 1, this is f. So it's 4 over 2, which is 2. So f prime of 1 is 2. Then we want to determine f of 1. F of 1 is indeed 2. And we also want to determine g prime of f of 1. G prime of 2. G prime of 2. So the derivative at 2 is this. Let me choose a grid intersection. 2 over 3, 2/3. Okay? Is that clear what I did? Should I show it again? So is it clear that f prime of 1 is 4 divided by 2? It's the slope of this line. And at 1, anywhere here, f prime of 1. But it doesn't matter, it's the same slope, it's a line.
Can you slide the book up to the tiny bit?
Oh, of course. Sorry. So, so f of 1 is 2. So this is the slope of the line, which is rise over 1. So I'm using the corners of the grid so I can easily read. And I have 4 divided by 2, which is 2. So that is f prime of 1. Correct? Okay. F of 1 is 2. But now what we need is g prime of 2. G prime of f of 1, which is g prime of 2. So 2 is here for g, and I'm trying to determine the slope of this line. Again, trying to find corners of the grid so I can read easily. And this is still positive, so the rise is 2 and the run is 3. Better? Okay, very good.
So,
Yes?
write that as your final answer.
No, I didn't. So just give me 1 second. We will write it right now. So I determined that f prime of 1 is 2. Agreed? We determined that this was 2, and we determined that g prime of 2 was 2/3. So then this is 2/3 times 2 over 1 if you want, and this is 4/3. So v prime of 1 is 4/3. Better? Okay. Let's look at the rumor. An application. 84. And then we'll go back to anything else you want. Ready? So, under certain circumstances, a rumor spreads according to the equation. So they have a function for us. How they came up with it? No idea. But they came up with it. It's a logistic growth model, sort of. Okay, where P of t is the proportion of the population that knows the rumor at time t, and A and K are positive constants. So P is a proportion, and T is time t. At time t. Okay, find the limit as t approaches, I'm assuming it's infinity, I have to look carefully.
Yeah.
As of P of t. And then find the rate of spread of the rumor. What does it mean? Does it mean the rate of the spread of the rumor? The
Rate change.
derivative, exactly, of course. The derivative, P prime, that's the rate. Find the rate of spread of the rumor. It doesn't say at a particular time, it says the function. Find P prime of t. Okay, ready? Clear for that? Is that clear? Okay, and then the graph, whatever we can do that. It has a calculator symbol there, we can plug it in. Okay, so let's do that. So this is 84. We will not be able, have not been able to differentiate this without the chain rule. That's why it's here. So we have P of t. So this is proportion, which is 1 over 1 plus AE, I think is minus KT. And they want us to find the limit, that's part A, as t approaches infinity from 1 over 1 plus AE to negative KT. What do you expect? Let's say a population of a city has, I don't know, 600,000 people. And we start a rumor in that city. As time increases to infinity, what do you think? What will be the proportion of people who will hear the rumor?
Time for infinity, all of it.
100%. The proportion has to be 100% if the time goes to infinity. Okay, so let's give it a shot. So when t approaches infinity, where does k, which is a positive constant, where does k times infinity go with minus in front? Negative infinity. Where does e to negative infinity go? Exactly. How much is 0 times a?
0.
How much is 0 plus 1?
1.
How much is 1 over 1?
1.
What is the proportion of people that will hear the rumor eventually?
1.
Which is 100%. Indeed. Part B. We are asked to find P prime of t. It makes sense, right? Good. So now let's see how we find P prime of t. And no, I'm not going to use the quotient rule, even if you force me to. Only because the numerator is a constant. Otherwise, I would have had no choice, maybe. I don't know. But I would have probably considered the quotient rule. But since the numerator is just a constant, I don't care for it, right? It comes in front. It doesn't mean anything. Okay, so now I change 1 over 1 plus e to negative kt into this. And because I know the chain rule, now I will do what? So let's find P prime of t. So of course, yes, this is differentiated because I put P prime of t, I have to put the derivative over there. Indeed, so it's negative 1 times
1 plus a negative kt. Oh, sorry, so negative 2.
excellent times the inner function prime. What is 1 prime?
0.
0. And then I'm here a constant times a function. So this is a. Now I'm differentiating e to a function.
Which is the same.
So it's e to negative kt times the inner function prime.
So,
I differentiate this and I get,
negative k.
indeed. Don't forget to put it in parentheses though, because it has a negative sign. Otherwise I wouldn't.
So that's pretty much just like an x. t.
Yes,
Treat it like that.
yes, when I differentiate negative kt, it's like negative 5t. So I get negative 5, correct. Now I have to rearrange it a little bit because this is a product. I don't really need to use these parentheses. I wanted to make sure that you understand what we're doing here. but these parentheses are redundant. These are not. So the -1 times the -k go in front. And of course, I will change everything into positive exponents as much as I can. So then P prime of t will be k, ak, over e to kt, and times 1 plus a e to -kt to the second power. So let's look again what just happened. So I have a times -k, which is -ak, with minus in front is ak. These do not have negative powers, they have to stay where they are. This one has negative power, goes to the denominator with positive power. This one has e to -kt, has negative power, will go in front with positive power in the denominator. So this is the function that gives the rate of change of the spread of the rumor with respect to time at any point in time where the function is differentiable. That's the rate of change. How fast is the rumor change? How fast is the rumor going through from person to person? What is the percentage of people? How fast does the percentage of people change? How fast does it change in time? At any point in time, if you say, I don't know what t is measured in, they didn't say. Time, it doesn't say. So I don't know if it's if time is in weeks, then when I replace t by 5, I'll tell you how fast is the rumor changing. What is the percentage or proportion of people at that time? Yes.
So when you drop that e to kt, that's
Yes.
not negative because it's pretty much acting as the.
No. It's a to negative power is 1 over a to the positive power.
Right. Okay, so that's why inside that function.
Oh, I can't touch that.
Right.
Yes, very good question. I can only discuss this. I cannot discuss that. But this one I can.
Because that's acting
by
like
itself. Yes, indeed. Here I can change it, but it's not going to make a huge difference. I can only change it inside parentheses as a over e to positive kt. But then I have to simplify it and move it up and yeah. So this is good enough, but very good point. Okay. I know I'm down to 15 minutes. We still work on this on another example? Yes? Perfect, okay. So let's choose, we were looking at 74. It looks, again, gibberish. We can look at 72. You choose. Let me zoom in. Okay, so here's 74. Right? That's 74. And here's 72. If g is a twice differentiable function and f of x is given blah, 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 find the second derivative in terms of 74. It's giving us some numbers and we're asked to find f prime of 1. Whichever you would like to choose, that's fine. 74 it is. I think already, Thane. Did you choose already, Thane? Is that what you said? You said 74? Oh. Good. I don't have to please 2 people. I only have to please 2 people who chose the same thing. Okay, 74. Show that the function, f of x is given as f of x, f of x, f of x. Okay, xf, and x, and 3 parentheses, correct. 1, 2, 3. We'll figure out in a minute. And I just need to copy the rest. F of 1 is 2, f of 2 is 3, f prime of 1 is 4, f prime of 2 is 5, f prime of 3 is 6, and we're asked to find f prime of 1. Did I copy correctly? So f
Yeah.
of x, f, so it's a product, so f of x times f of x times f of x and 3 parentheses. Perfect. Okay, let's do this together. So first, I'm asked to differentiate a function of a function. So obviously I can't even look at all this. I have to find f prime of x first. So that means nothing at this point. So when I differentiate a function of a function, I have f of the function, and now I have to copy it. X times f of x times the inner function prime, but it's a product. Okay? So the function of a function, f prime. So the outer function, f prime of the function, times the inner function prime, but it's a product. So this is function 1, and this is function 2. Don't even look at it just yet. Okay, so I differentiate the first function, I get 1, and I copy the second function, which is f of x. Plus, I copy the first function, and now I have to differentiate this one. I'm differentiating a function of a function. So this will be f prime of, and I copy it, times x f of x prime. Okay, let's regroup. Let's go through the process one more time. It's not done. Okay, so I have f of a function prime. It's f prime of that function times the inner function prime. But the inner function is a product of two functions. I don't even want to look at this. It's x times whatever. I differentiate the first function, I get 1, and I just copy the second one, plus. I copy x, but now I have to differentiate this. How do I differentiate this? The outer function prime times the inner function prime, which I did not perform yet. Does it make sense? Marty's asleep already.
That makes sense.
Does it?
Yeah.
Okay. So it was a product, first function times the second, plus the first times the second prime. But I have not completed this, the last part. But now this is a product. So I have to use the product rule again. So this is the first function and this is the second function. Careful, we need to copy everything without changing anything. So f prime of x, f of x times f of x plus x, f prime of x and times a sum, because I'm using the product rule again. This is number 1, and this is number 2. The first function prime is 1 times the second one, plus the first times the second prime. Impossible to simplify, what we will not even try, and we don't have to. Now all we have to do is plug in those numbers where they fit and find f prime of 1. That's all we need. No, I'm not going to put something like this on the test. It took me together with you 5 minutes, so no. But it's interesting to see just every now and then a problem like this. So then f prime of 1. I'm not intending to torture you. I'm intending to just test your understanding. So anyway, so here's what we have. X is 1. So f and 1 and f of 1. F of 1 is 2. So this is 1. This is 1. This is 2. This is 1. This is 2. This is 1. This is 1. This is 2. This is 2. This is 1. And f prime of 1 is 4. Okay, so say it again. X is 1. So how much is 1 times 2? 2. How much is f of 2? F of 2 is 3. So 3 times 1. So this is f prime of 3. So this is 1, this is 2, so this is 2. F of 2 we're given is 3. And 3 times 1 is 3. So then f prime of 3. I didn't put it in yet. Okay, times. 1 times 2 is 2. Again, f of 2 is 3. 1 times 2 again is 2, but f prime of 2 is 5 times 1. And then times, this is 4, yes. 4 times 1 is 4. 4 plus 2 is 6. And then I only need f prime of 3, which is 6. So this is 33. Plugging in those numbers was not a big deal, but differentiating, it's a long process for this function. Any questions? It gave us a headache?
Yep.
Yeah, it was a little intense.
That's one way of putting it.
One way of putting it, I agree. Okay. Implicit differentiation. If I'm given a function f of x equals x cubed plus 2x, and I'm asked to find its derivative, what will you say? You'll say it's a piece of cake. This is 3x squared plus 2. Correct? Okay. But what if I'm given something like this? I'm challenging you to solve this equation for y. No one can. Probably the software calculator, a computer software will probably take who knows how long. We can't solve this. But I still can determine an expression for dy over dx. So the function is not given directly. We cannot directly differentiate like we did here. The function was given to us, we were directly differentiating. Here, we're going to differentiate implicitly because we can determine the function. We can solve this equation for y. So there's still a way of determining dy over dx. However, it will depend on y, obviously. But I can still determine an expression for dy over dx. Every time we work on implicit differentiation or apply the implicit differentiation, please use this notation. You will see why. It will could get very confusing, and you may not be able to solve correctly. So whenever we differentiate implicitly, which means I apply the same procedure to both sides. Like I'm adding 5 to both sides, like I'm subtracting 10 from both sides, or multiplying both sides by 5. It's the same procedure. We differentiate the left-hand side, we differentiate the right-hand side. Now, what do I know about y? It's a function of x. This not only tells me to find y prime, or an expression for y prime, but it also implicitly, or indirectly if you want, it tells me, careful, y is not a variable, but a function of x. Okay, so let's differentiate. The left-hand side, using implicit differentiation. Sine of a function, prime, is cosine of the function times
The function.
the function prime. Very good. This is the derivative of this piece. Plus, I'm differentiating y squared. 2 y to 2 minus 1 times, very good, equals now, but these are two functions, and this is a product. Therefore, I have to apply the product rule. One function is x cubed, the other function is y, that I don't have, but it's a function of x. So when I differentiate x cubed, what do I get? Very good. Times the second function plus x cubed times the derivative of the second function, which is dy over dx. Remember, this is the variable now. This is what I am going to solve for. This is a linear equation. All terms with dy have to be on one side. The other terms without dy will be on the right, and I'm going to solve for dy. From this point on, it's a linear equation piece of cake. But it's not always that easy to come up with this, the form that we have right now. So I will move this term to the other side and factor out dy over dx. And the right-hand side is only 3x squared y. So cosine y is positive, plus 2y positive, but I'm bringing this from the other side, so it's negative x cubed. And finally, I want you to tell me what does dy over dx equal to?
3x squared
Of course,
y over
everything over that. Cosine y plus 2y minus x cubed. And this is implicit differentiation.